Okay, we're going to solve this problem. So first, if you read, we're going to try to find this cubic function, and they give you a couple clues. Number one, they give you this general form, and all you're supposed to do is find the c. But they give you another clue, which is helpful, which is this this one of the zeros. So because this has a square root, and because it has an I, that means he travels in pairs, meaning his conjugate, his complex conjugate, is 1 minus I root 3. So you just, in reality, all you're doing is changing that sign in the middle from a plus to a minus. And they always travel in pairs. If you get one, you always have to get the other, no matter what. So because they gave you two zeros, that means you can therefore find the factor by solving for 0. So you move the 1 over, you move the rest of it over so that you get the equation equal to 0. And so that's going to be a factor. Right here, this is a factor. And you do the same exact thing with the other factor. So now I have two factors, right? And so whenever you have factors, you can multiply them out so that you can find more of the function. So I use what's called the box method because it keeps everything organized. You write your factors along the top and the side, and then you just multiply every single piece. So the first box gets filled with x squared because x times x is x squared. And negative x comes from x times negative 1. And you just keep filling it in. X times I root 3 is xi root 3. Looks ugly, but keep following. It'll go away. The next row, you just again multiply negative 1 times x again, and that's negative x. And you do this all the way through. And some of it looks ugly like that negative I root 3, but it'll turn out pretty in the end. And you just follow all the way through. Just a little reminder, I squared is the same as negative 1. And then when I pull in that negative, it turns into positive 1. When I pull in that 3, it just turns out to 3. So that whole box is now equal to 3. So now we have to add all the like terms within this whole box right here. So add all like terms, anything that's alike. So I'm trying to look at these ugly I root 3's and notice they're opposites. One's negative and one's positive. So those are going to cancel. If you also notice, these two are also opposites, so those are also going to cancel. And if you notice all the ugly pieces, like all the stuff with the eyes, all the stuff with the radicals, they all cancel. So therefore, I have all these things left. X squared, negative 2x, the 1 plus the 3, that's 4. So x squared minus 2x plus 4 is a factor of this cubic right here. Okay. Now what we want to do is we want to find this c. Now the best way to do this is if you pretend that it's a perfect cube. So that x cubed is going to turn into x cubed plus like some number cubed. And so I'm basically saying that I'm forcing it to be a cube so that it's the fastest way to find that c. And so if you remember, cubics, whenever it's a perfect cube binomial, it factors like this every single time. This is like a fact. So one of the pieces is x plus b, and the other piece is x squared minus bx plus b squared, which this right here looks exactly like over here, right? So I write that right underneath, and it matches perfectly. So therefore, b is 2. See how these two match up because everything else pretty much matches up, and b squared is 4. Since now I know that b is 2, I can write x cubed equals 2 cubed, which is 8, right? And so therefore I'm saying that c is 8. That's pretty much it. All right.